howdy and welcome back. So we're kind of at the point where we've maybe deserialized from some data from some sort of collection. Now we're interested in interacting with it within our program. One operation that we might want to do is to go ahead and sort that data according to some sort of um, criteria. So let's assume we've read in a collection of movie objects from a file where they were stored in CSV format. So they've been deserialized and now they're stored in a standard library vector called movies. Let's say then we'd like to sort the movies within this vector in alphabetical order. That is going to be possible to accomplish using the standard library's sort function, which is defined in algorithms. Algorithm, that's singular, not plural. Let's go ahead and decompose the arguments to this function, and we'll pay a little bit of special attention to this third one here. So sort, in order for it to operate, it needs to know the kind of elements that are within the collection that it's going to put into some sort of desired order. The first argument is going to be the beginning element. This returns what's known as an iterator. We haven't covered this yet, but for all intents and purposes, you can think about this as a pointer to the first element in the collection. So again, movies.begin, you can ask the movies collection or movies vector, what's your first element? And let's again assume that we get a pointer back to it. And we can go ahead and store that somehow to use it and actually move, because remember, in a pointer, you can dereference where you currently are. And there's also pointer arithmetic that would allow us to move from one element to the next, similarly to how we could move from the base element in an array to the adjacent element by adding one onto that. Begin is going to be one past the last element within this collection. So n is going to be a pointer here. And the reason why it's one past the last is that if we're traversing this collection of movies, say using some sort of movie pointer that's initialized to the first element, which would be similarly to initializing a pointer to the base element in an array, and then adding one onto it, we'd get to the adjacent element, in this case, our movie Casablanca. We wouldn't know that we've visited every element until we've actually visited every element. So we only know that once we've actually passed by the final element in that collection. In this case, once the current pointer, essentially that we're using to track where we are, is equal to this pointer that's one past the last element, we know we visited every element within the collection and that there is no more work to be done. So in this case, sort's working similarly. It's saying that, okay, from the first element in the collection to the one past the last element in the collection. So for every element in our movies vector from the beginning through the end, we're going to do this sort operation, which is defined by this function. This is a user-defined type. We've never said what it means for, say, one movie to be less than another movie. So how do we communicate how we'd like this to be sorted? Well, we could have defined operator less than. We could have overloaded this operation for movie type, and we could have specified some sort of criteria. And then in that case, we could have just invoked this function with sort movies.begin, movies through end. Because we haven't defined this criteria yet, we're going to go ahead and essentially pass to sort an anonymous function or a lambda function that is going to tell it how it should perform the sorting of objects within this collection. So here we have the lambda introducer followed by the parameter list, which is optional, but for this particular function, we need to pass in two movie objects, or the two movie objects under comparison. So in this case, by constant reference, we'll pass a movie object identified by A, one by B, and then the actual sorting criteria follows. We're going to return whether A's title is less than B's title. If this evaluates to true, the sort function here knows that those elements do not need to be swapped or moved in any sort of way. If this returns false, we know that they are not currently in order. And then the definition for this function will go ahead and carry out whatever steps are necessary to ensure that by the end of this statement, the elements in our movies vectors are sorted in alphabetical order according to their title. And as we can see here, based on how that's written, at the end of this, the outcome is that Casablanca comes before Gone with the Wind, and the elements of movies have been sorted.